Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 87 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. What I'm going to do is I'm going to show you my solution to the homework assignment that I gave you last week. Last week, I showed you how to read the data coming from the magnetometers on the GY87 module. You had the X value, the Y value, the Z value for the three magnetometers, how to read that data in using the Arduino. Okay, what your assignment was to go away and to calibrate those numbers that were coming off of the GY87 magnetometers, and then to convert those raw numbers into a heading or a yaw or a compass reading of what direction you were pointing. Okay, and so that is what we are going to do today. But to get started, we probably need to go ahead and kind of talk about what our strategy is going to be. So we're going to try to sketch it out on the old sketch pad. And what I will do here is I will get out of your way. It will come in and we'll kind of try to draw this thing out. Okay, so in an ideal world, which we don't live in, but if we lived in an ideal world, this is what the data would look like. This is what the data would look like coming off of the magnetometers. It would be a circle, okay? So as we rotated in the XY plane 360 degrees, the reading from the X magnetometer and the Y magnetometer, if you plotted X comma Y for your readings, it should form a perfect circle, okay? But what happened when we did that? Did we get a perfect circle? No, we did not get a perfect circle. We got something like this, okay? We got something like this, all right? And so what is the first problem? The first problem is the circle that we got was not centered at the point 0, 0. It was centered some distance down and some distance over. So to do the calibration, the first thing that we are going to have to do is we are going to have to calculate our offsets. Okay, now it's only easy, offsets. It is only easy to draw the two axes, so I'm drawing X and Y, but you've got to also see that you have an offset in Z. So I have to calculate those offsets so that I can move this point over some X and over some Y to move my circle from here to centered on 0, 0. So I'm going to have to calculate three offsets. So the first offset that I'm going to have to calculate is the X offset. Now, what is it? Where is this midpoint? Where is this midpoint? Well, if this is x max, the maximum x value that I measure, and this is x min, the minimum value that I measure. What is the center point? Well, it's just the average, the x max plus x min divided by 2. So the offset in the x direction is very simply x max plus x min divided by 2. And then what I will want to do is I will want to take my center point, and then I would want to subtract the offset, and that would move my circle centered right here. Well, now I'm also going to need to what? I'm going to need to move it up. So I'm going to need a y offset. And that's going to be equal to, very simply, y max plus y min divided by 2. Okay, and then that is going to move the center up to where? 0, 0. So I've got to calculate my x offset. I've got to calculate my y offset. And then again, this would be the y max that I see in my raw data, and this would be the y min. So I make those 4 measurements, I determine those 4 values. Now I can center on 0, 0, but I still got to do the z, right? The z is into the page, it's hard to draw, but you can easily see it would be the same thing. The z offset is going to be equal to z max plus z min over 2, z max minus z min over 2, and that's going to be the z offset. So now I have the offsets, but still my circle might not be the right size. For the trigonometry to work, we really want it to go from +1 to -1 in x, from +1 to -1 in z, and from +1 to -1 in x, from +1 to -1 in y, and from +1 to -1 in z. Okay, so that's what we need to do. So I need to do those scale factors. Well, how would I do the scale factor? Okay, the scale factor is going to really be pretty simple. The scale factor, I'm trying to think, how would we describe the scale factor? Give me just a second here. I'm trying to think if I really want to kind of draw a picture of it. The scale is going to be if I take I want from here the maximum to the minimum, I want that to be 2 because I want it to be plus or minus 1. So I want that span to be 2. So what would I do? I would say the x scale correction, I want to multiply 2 by what? By 1 over x max minus x min. Okay, and you didn't see that, but let me move out of your way. Okay, so what is my span right now? My span from here to here is x max minus x min. So I want to divide that out, and now my span would be what? It would be 1. But I want the span to be 2, so I multiply by 2. And similarly, my y scale correction is going to be 2 times 1 over y max minus y min. And then my z scale correction is going to be 2, and you guessed it, it's 1 over z max minus z min. So now what do I have? I have my 3 numbers to correct the scale. so that my circles are between plus and minus 1. And then I have my 3 offsets where my point is moved from wherever it is to the point 0, 0, 0. Now, to get a calibrated number, I just apply these values as, first of all, I want to get them in the right spot, right? I want to get them in the right spot. So my X compensated, my X calibrated, let's call it X calibrated, my X cal is going to be equal to what? The raw number, and then what? I want to subtract the offset minus the offset times the scale. And what will that do? It will move all the points centered at 0, and it will scale them between 1 and minus 1. Now the X calibrated is X raw minus X offset times X scale, and the Y calibrated is Y raw minus Y offset times Y scale, right? So you've got to kind of do all 3 of them. Now we're going to break this into 2 parts. The first program is going to find the minimum and maximums of X, Y, and Z as we move through all possible orientations, okay? And then it is going to calculate my offset values and my scale values. Now the second program, I just put in those offset and scale values, and then I take the raw magnetometer readings, and then I calculate the calibrated magnetometer readings, and then I can do the simple, the heading or the yaw is the arctan2 of the Y calibrated over the X calibrated, or the Y-cal, X-cal, if we're using the Arduino arctan2 function. Man, I hope I didn't just send you all back to culinary arts or something like that. I'll tell you, I hope I didn't confuse you or intimidate you, because it's going to be a pretty straightforward thing to do. And so what are we going to do? We're going to go back to the code that we ended up with last week, because the code that we ended up last week was doing what for us? The code that we had last week was actually making the measurements for us. And so we're going to go to using the QMC5883L magnetometer, and we're going to get that simple code that just does the raw readings. Okay, we're going to get that simple code that does the raw readings, and then we're going to paste it here. And then here, if I just run this, what should I see? I should see no errors, and I should see live X, Y, and Z data coming from the 3 magnetometers. Okay, it's looking pretty good, isn't it? Looking pretty good. Seems a little slow to compile, but it looks like it's going to work. And then we're coming up here. It is compiled. We'll turn the serial monitor on. Yeah, and we're getting beautiful live data here. We're getting beautiful live data. That looks really good. So we're making readings. Now I can see that my maximum X value, should be somewhere where my X axis is pointing north. And remember, we oriented my pad last week where these lines this way are the perfect north-south line. So if I put this here, this should be my maximum X value. And look, I'm almost 600. And then as I start turning, I'm coming down to the 3s and 2s. Or if I go the other way, I go from about 600 and I start coming down to the 5s and the 4s. And you can see that that is pretty nicely oriented in the north-south direction, because my maximum X value is when the X-axis is pointing perfectly north. Okay, but I've got to find X max, X min, Y max, Y min, Z max, Z min, and then I've got to calculate the offsets, and I've got to calculate the scales. Now I could do this by just sitting here and moving this around, and writing numbers down, but I want to kind of automate it a little bit. So we're going to play with this code, and what we are going to do is I've got the integer values X, Y, and Z, and let's see here. What I'm going to do is, because I'm going to be doing calculations these times to correct them, they're not just going to be raw numbers coming in, so I'm going to change that to a float because I'm going to be multiplying and dividing and all that sort of stuff. So my X, Y, and Z values, my calibrated X, Y, and Z values are going to be float numbers. Now what I'm going to need to do is I'm going to need to have an X max value, okay, and I'm going to have to find that. And so what I'm going to have to find is my X max, my X min, my Y max, my Y min, my Z max, and my Z min. Now, why did I make those integers? Because those are going to be taken directly from the raw data, and the raw data comes in as integers. So that's what I'm going to have to do there. I've got all of those, and now I'm going to have to get my correction values. And what are my correction values going to be? It's going to be the X offset and the X scale, and it's going to be the Y offset, and it's going to be the Y scale. And then it's going to be the Z offset, and it's going to be the Z scale, like that. I'm just going to check it. Offset scale, offset scale, offset scale. I think that looks good. Max min, max min, max min. Okay, so I think those are pretty much going to be my variables. Okay, those are going to be pretty much my variables. And then I've got this thing set up to run. And then here I am making my measurements. Okay, I'm making my measurements. And actually this time I think I need to keep my X, Y, and Z as ints because I'm not applying the calibration yet. I'm just calculating the calibration. So now I read X, Y, and Z. Now I've got to find, is it a max or is it a min? Okay, is it a max or is it a min? And you know what I'm going to have to do? I'm really going to have to do these individually. I'll fix this because what I got to do is I got to give it initial values, okay, for these values, because you have to start them somewhere if you're going to use them in an if statement. You got to initialize them to some value. And so this, okay, so now we need to put our semicolons in. Now I've got to set these to some initial value. So I want the maximum to start out really, really, really low. So then it finds the real maximum. So I'll just say equal minus 10,000. And then I want the initial minimum value just to be huge so that it be sure and finds the real minimum value. So I'll put 10,000. And then this would be minus 10,000. And that would be an equal. And then this would be equal 10,000, 10,000, and this would be equal minus 10,000. I did that strange. This is max min, max min, max. I did that right. Min, okay, is equal to 10,000. And that just ensures that any reading you have would be, more than minus 10,000. So it's going to find the real values. Okay, so I'm going to have those, and then I have the offset scale, Y offset scale. Those I'm just going to calculate, right? Those I'm going to calculate as I'm going, and so those should be okay. So what am I going to print? I'm going to measure X, Y, and Z raw. Okay, now I've got to find the maximum and the minimums, and so I'm going to have to say if X is greater than X max, if X is greater than X max, now what? I have a new winner. X max is equal to X, like that. I'm going to make sure been putting my semicolons in. Yeah, I think so. Now, we're going to find the x min. If x is less than x min, then what do I have? I have a new loser. So x min is going to be equal to that x. Does that make sense? I'm always hard pressed if I should just copy and paste or keep typing. Z less than z min, or z, let's do it the other way. If z is greater than z max, I need to look here. I just had a thought. I think I need parentheses here, don't you? I think you got to put parentheses around your if conditionals in Arduino, if I'm remembering right. I think maybe these need to be in parentheses. Like this, okay. Now, if z is greater than z max, then we have a new winner. Z max is equal to z, semicolon, semicolon, okay. And now if z is less than z min, we have a new loser. And what is that going to be? Z min is going to be equal to z, like that. Now let's check this kind of carefully because it's easy to get up. X greater than x max, we have a new x max. X less than x min, we have a new x min. Z is greater than z max, we have a new z max. Okay, if z is less than z min, we have a new z min. So I think we should have there our maximum and minimums at this point. Now, what we can do is we can calculate our scales and our offsets, right? And so what is my x offset? My x offset is going to be equal to x max plus x min, x max plus x min divided by 2, semicolon. Okay, I think I'm going to try to copy and paste here. All right, copy, and we're going to need to do the y's, we're going to need to do the z's, and so this is going to be y, and then this is going to be z, z, z. Now, it's going to calculate x offset, y offset, z offset every time, but they're not going to be good until I rotate this thing around through every possible orientation, and then I should have the real maxes and min values, and then I should have the real offset. But I'm going to calculate them each time through, and as I rotate these things, they'll get more accurate. Now I need x scale, and x scale is going to be equal to, x scale is going to be equal to, what did we say that x scale was going to be equal to? Somebody tell me how we were going to do that. How are we going to do that? And the way that we were going to do that is that it is going to be 2, and really because we're doing floating point math here, right, on these offsets, those are floats, so we better make sure that we're using floating numbers here just so that we don't get goofy things. So it's really kind of safe to put that in. So it is going to be 2 divided by, it was going to be what? X max minus x min, like that. Okay, and then we're going to do that x scale, we're going to do that for y and z. So we're correcting each axis. So this is going to be y, and this is going to be y, this is going to be y, and then this is going to be Z, and this is going to be Z, and this is going to be Z. And remember, these equations I came up with over on the sketch pad, so go back and look at that if you don't remember these. But that is going to be good, I think. I should really do Control T's more often to line up and fix my formatting a little bit. So there we go. So we've got those now. Now I'm going to print X, Y, and Z. Those are the raw data, okay? And then what am I going to print? I want to do a serial dot print, and I want to print X max. That'll be the fourth column over. Then I want to take this ln off because I want them to all go across. So I'm going to do the X max, and I'm just going to copy that comma. Okay, so I got that. What is this S? Where did that come from? Okay, so I'm going to do the comma, and then I am going to do a serial dot print. And then I'm going to print the X min. And then I'll print the comma. And then I'm going to print the serial dot print. Syria. Be quiet, Syria. I wish I could make Syria completely go away. All right, so now I'm going to do the Y max, and then the comma. And then I'm going to try to do a Control T to straighten that up. And now serial dot print. And I'm going to do the Y min. And then my comma. And then serial dot print. This is going to be the Z max. And then serial dot print is going to be the Z min. I forgot the comma, but I'll put it there, Control V. So I've got X max, X min, Y max, Y min, Z max, Z min. So that's all good. Now I want to print the continuing to be updated. What am I continuing to update? I'm going to print the X offset, Y offset, Z offset. Man, this is going to be really long across there, but we'll see if we can get it on there. So now I'm going to do the serial dot print, and then this will be the X offset, and then we're going to print the comma, and then the serial dot print the Y offset. We just want to watch this data as it's coming in, seeing if we're getting a good calibration. And then serial dot print, and then Z offset, and then put in our comma, and then serial dot print. And then I want to make sure, what did I call it up here? I called it the X scale, Y scale, Z scale. And so this is going to be X scale correction, the comma, serial dot print, Y scale print, and then serial dot print Z scale. Syria is very determined to be listening in on our little private conversation here, which really bugs me. Okay, so now I've done all those printings. Let's see if we can tab those things straight. That looks good. And now we'll do a delay, and then here we need to do a print ln, and my goodness, we're like 72 lines of code. There's no telling what's going to happen here, but let's just see if this thing will run, and let's see if what we get. We got like 3 3 3 3. We got like 12 numbers going across there, but let's see if we can make any sense of it. Okay, yeah, look at that. So that's looking pretty good. So you see this X is at like 500, 510, something like that. And then I'm getting very odd numbers here for the X max, Y max. So those numbers don't make any sense. I've got X, Y, Z, and then I've got X max. And those things are not, yeah, they are updating. Okay, I've got like a, did I leave a comma out there? Maybe I left a comma out, and that's why I'm seeing those really strange numbers. So let's see, I've got the XYZ, and I did leave the comment, the comma out. And that's why I'm seeing this really big number here that didn't make sense. So let's try this again. Okay, so I've got the X value here in the first column, and it's about 500, 520. And then look at this X max, it snagged the X max at 521. So it looks like I've got a good X max there, right? And if I move it around, okay, I got a little bit higher X max. I got an X max up to like 550, 560, something like that. So I got a bigger X max, okay? And so I got a bigger value there. And I'm moving it around, making sure I've got the maximum X. And then what comes after maximum X is minimum X. Let's make sure how we're printing. And we're printing X max, X min. Now I'm looking at the 13. As I rotate it, I should see a number lower than 13. Okay, let's see. So my, yeah, I should get a number lower than 13. I'm still looking at X. Yeah, now you see the 560 and then the minus 300. So what am I doing? I am finding the actual X min as I'm rotating this. And as I get down to south, then I'm like at minus 1200, and that is the real minimum. So I think now, I think I have my X max, and I think I have my X min, and then out here somewhere is probably my offset values. Okay, somewhere out here are probably my offset values. So X max, this is X, Y, Z, X max, X min, Y max, Y min, Z max, Z min. And so this is probably my offset, and then my scale is not really right there. So somehow it looks like my X scale 2 divided by X max, X min. So that is probably not exactly right, but we'll figure out what that is here in a minute. But let's go ahead and let's see if we can get the Y max and the Y min. So this is Y. And now if I point the Y axis north, you see I'm getting 1200, and that should be recording 1200, but that looks like something kind of strange there. So this is X, Y, Z, X max, X min. So the Y doesn't seem to be updating. So I made a mistake on my Y max and Y min. So let's see. I say if X is greater than X max is equal to X. If X is less than X min, then X min is X. What happened to my Y? I didn't do my Y. No wonder it didn't work. I thought I did my Y. Okay, if Y is less than, well, let's say if Y is greater than Y max, then what do I have? What do I have? You tell me. What I have is I have a new Y max, and that's going to be equal to Y. How did I not get this in here? Now, if Y min is, if Y is less than Y min, then what happens? Then I have Y min is equal to Y semicolon come up here, semicolon. So now I should be getting the y value, and that's why these things were probably not working right. So this is x, y, z, x max, x min, y max, y min, z max, z min, and then these should be the offsets, all right, and then these should be the scale. So I think then, right, I printed x max, x min, y max, y min, z max, z min, and x offset, y offset, z offset, s scale, y scale, z scale. Okay, let's run this again. It's kind of hard to look at that string of data and really see what things are, but let's try to orient back to north again. All right, so now my x max is sitting there at 400, and if I tweak around north, okay, it's kind of locked in. The highest that it saw, it's like x, y, z, and this is x max. The highest x it saw was 471. Now, if I turn it all the way around, now this is x min, which is like minus 1100. Okay, so I've got my x max and I've got my x min. Now let's try to get my y max and my y min. To get the y max, I need to point y north. And here I'm kind of dialing in my y max at 1200. And now I want y min, which I'll get from pointing south. And let's see here. Yeah, it's about minus 4 something if I look at that second number. So that makes sense for a y min. And then the y max is indeed around 1200. So that looks good. Okay, now I need to get z max and z min. So what do I have to do? I have to point z. I have to point z towards the magnetic vector. So I point z. Now z is pointing towards the Earth's magnetic field, and I'm getting a maximum value of there like 1800. Okay, and now if I point it south, it should give me the z min. Okay, now I'm pointing against the vector, and this is my z, and the minimum z is sitting there about 90. And so this is x max, x min, y max, y min, z max, and z min, and that z min of 68 looks right. Okay, so that's really good. And now what do I like? What I like is x max, x min, or it's x, y, z, x max, x min. Did I lose that? I think I might have lost that when I reset it. Okay, let me just do it again really quick. But okay, what the problem is now, the last 4 numbers, so my scales, my offsets I'm calculating, but my scales aren't. And so why am I getting on x scale, y scale, and z scale, why am I getting what looks like zeros? Okay, it could be that, you know, if you have like 1, if you have 2 divided by 1,000, it would be 0.00 something. And so let's come down here, and on these final things, the scale, let's say, let's print to 5 decimal places like this. All right, so now let's do that, and let's just see if it's just, you know, I want to go between 1 and -1, and I'm spanning 1,000, so that correction would be like a 0.00 something. So I think that's probably what was happening. Okay, so now I've got x pointed this way. I'm going to find x max, y max, x min, and y min by spinning this thing in the XY plane. So what am I doing? I'm showing that X and Y, the maximum possible and the minimum possible, the maximum and the minimum possible magnetic fields. So yeah, look, now you see these scale factors are right, okay? It's just they were too small to see a while ago. So now I should have X max, X min, Y max, and Y min. And so now I have to show Z. The Z, I have to show that Earth's magnetic field. And this should be giving me Z max here. And then when I come over here and point south, that should be giving me Z min. Okay, so now what do I have? I have my offsets. All right, so I'm going to write those things down, and you need to write yours down. But remember, this is X, Y, Z, X min, X max, X min, Y max, Y min, Z max, Z min. Now this would be the X offset. So I'm going to have the X offset is equal to minus 382.5 for me, okay? And then the Y offset is 378.5, 378.5. And then the Z offset is going to be equal to 1014.5. And now what do I have? X scale. X scale is equal to 0.00121. The Y scale is equal to 0.00115. And then the Z scale is equal to 0.00105. Okay, so I've got those written down, and now this device should be calibrated. Okay, this device should be calibrated. So what I'm going to do is I'm just going to come up here. I'm going to say new sketch. And I'm going to go back and get the program that was just printing the raw values, right? I'm going to go back and get the program that was just printing the raw values. Let's see here. Okay, so we're back at www.toptechboy.com. We are going to get just the raw program that was just printing the raw numbers. Okay, and so we're going to come and we're going to paste that. And now what do we want to do? We want to apply those calibration numbers. So yes, we're going to measure X. Yes, we're going to measure Y. And yes, we're going to measure Z. Okay, but now what do I need? I need to say that the X, and I'm going to go ahead and I'm going to make X, Y, and Z floats like that, because I'm going to be applying the correction factor. So what did we say that it is going to be? It's going to be the raw number here, and then what do? We subtract the offset, and so this would be the X offset, and my X offset was I really should come up here and put the numbers in, shouldn't I? Yeah, I should come up here and put the numbers in. And so what I'm going to do is I'm going to say float, and it's going to be the X offset is going to be equal to minus 382.5. Your number will be what your number is. Float Y offset is going to be equal to 378.5, and then float Z offset is going to be equal to 1014.5, like that, and then the X scale was equal to 0.00121 for me. The float y scale was equal to 0.00115, and then my z scale was equal to 0.00105. Now, what's the good news? You don't have to do this every time. Once you calibrate your sensor, you just leave these numbers in there. Okay, so those are the calibration factors. Now I have to do the calibration. So the compass get x is the raw number. What do? I subtract x offset, and then I multiply by x scale, like that. So even though that little bit was a little bit painful, I think you can see this is going to get easy now. So we're going to say minus the y offset times y scale, and then get z is going to be minus z offset times z scale. All right, minus z offset times z scale. All right, now the x, the y, and the z, now those are the what? Those are the calibrated numbers. So what do we expect now? Now as I spin this around, I expect x to be between 1 and -1 and y to be between 1 and -1. And how well this works depends on how carefully you find those x max, x mins, y max, and y mins, and so forth. Did I forget a semicolon somewhere? Expected some sort of token. You guys probably saw it. Where is my problem? That extraneous parenthesis. All right. I found that pretty quick. I don't feel too bad. Seems to be kind of slow compiling today, doesn't it? All right, it's uploading. Okay, let's turn that serial monitor on. Look, what do I like? The x and the y and the z are between +1 and -1. And if I point due north, when I point due north, I'm getting an x value of 1. That is great. If I point due south, I am getting an x value of -1. Now let's show the y-axis south. The y-axis south is now -1, and the y-axis pointing north is getting a 1 in y, the second number. Now let's show z. Let's show z the full magnetic field by pointing z north, and we are getting very close. We are getting very close to 1, okay, but not quite. What does that mean? That probably those z calibration things we didn't do as carefully as we should. Okay, and now we come here and we're very close to -1. So we probably just need to do our calibration a little bit more carefully and a little bit more deliberately, but that is actually very great. Now we have one last thing to do, okay? And what we're going to do is we're going to come up here and we're going to add a float for our heading, which you could also call yaw if you wanted. And then what we're going to do here is we are not going to print those things anymore, so I'm going to comment those out. Okay, and what are we going to do? We are going to serial.print, and we're going to say heading, like that. Okay, you could call it yaw if you wanted to, and then serial.println, And then what are we going to call that? We are going to call that our heading that we just calculated. Okay, did we calculate heading? No, we didn't, did we? So we got to now calculate heading. And so the head is equal to what? The arctan 2 that we talked so much about, y comma x, our SOHCAHTOA there. And now we're going to do that. And then let's run this thing. Man, I hope this works. This has been a little tedious, right? We're trying to do a lot in this lesson. I'm hoping we're not running too long with this thing. I know you guys start getting anxious when it's over 30 minutes, and really an hour is the attention span of just about anybody. Okay, now, what is it that I like? I'm getting just about 0 when I'm pointing due north, 0 degrees. That's good. Let's go to east, and I am not getting 90 degrees. Someone tell me what I did wrong. Why am I getting just 1.5 seconds? Because arctan reports in radians, and you've got to convert it to degrees. So I say times 360 degrees in a circle divided by 2 divided by pi. So there's 2 pi radians in a circle. So I divide out the 2 pi, the radians, and I multiply in the degrees. And so let's try that now. I'm so excited. Okay. Okay, so the heading here, I'm reading -6, -5. So I'm reading, maybe a 5-degree error here. I'm pointing due north, and I'm reading -5 degrees. So I've got a 5-degree error, but it is generally north. And now I'm going to point it east. And at east, I've got 86, 87. So I've got a 3-degree error. And then when I point south, I've got 174, 175. I've got a 5 or 6 degree error. And then if I point it west, I'm pointing the front of the device west, and I've got a -94, -95. So again, a 4 or 5 degree error. Boom. Okay, guys, this is pretty exciting. I've got the whole thing working, where now I have a digital compass that's accurate to within 4 or 5 degrees. Now, what if we wanted it to be accurate better than that? 2 things. I need to more carefully get the max and min by tweaking it around those 4 orthogonal points. Like here, I've got to carefully tweak it. And then here, I've got to carefully tweak it to calibrate it better. And then, when I'm like this, I've got to really find the Z. And when I'm like this, I've got to really find the Z max, the Z min. And if I find Z max, Z min, Y max, Y min, X max, X min better, I could get probably down to 1 or 2 degrees. The other issue is I am too close to the monitor. So if you watch this, as I get closer and closer to the monitor, do you see how I'm getting different and different readings? And so just for me to be able to do this where you can see it, I had to calibrate it a little bit closer to the monitor than what you would want. But I would say that this is pretty darn good, and I hope I didn't just wear you weary with this lesson, but you now have a calibrated digital compass where you can measure your heading from your magnetometers. Okay, so where are we going to go from here? So, we've gotten to the point now we have a good heading or a good yaw from the magnetometers, and we would want to fold that back over into our old program, where then we would have an accurate yaw, an accurate pitch, and an accurate roll. But we would be getting the yaw not from the gyro, but from the magnetometer. Now you might ask, are we going to want to roll that magnetometer in with the gyro? Well, we might, because if you were really using this for a fast-moving application, there would be advantages to kind of putting a complementary filter to sort of combine the gyro and the magnetometer data on that yaw. But right now, that's not going to be the next thing we are going to do. What we're going to do is we're going to kind of go the next level. You see that this calibration scheme works, but the problem with our calibration scheme is it's just sort of hard as we are sitting here. It's sort of hard to really dial in those max and min values because we're just looking at these numbers scrolling past. And how many times was I trying to count over to see which column I was in? It was kind of hard. So we need a better way to help us calibrate more accurately. And so I think next week what I'm going to do is, you can do this as a homework assignment if you want, but what I want to do is I want to transfer this raw X, raw Y, and raw Z that's coming from the Arduino. I want to send it over to the desktop to Python. Okay, and then in Python, using PyQt, I want to graph my X and Y data, and then graphically I can see when I'm right on the edge of that circle, and I can try to make sure that I'm really getting the maximum and minimum values by looking at a graph of the XY plane, the XZ plane, and the YZ plane, and then I can really dial in a more perfect calibration. And with a more perfect calibration, what would I be able to do? I would be able to get better than 5 degrees and more like probably 1 degree accuracy in my yaw reading. So that's what we're going to do next week. We are going to connect to PyQt on the desktop, and then once we're in PyQt, we'll be sending the data over there from the Arduino, and then what we will be doing is we will be plotting plotting the data, which will allow us to calibrate it better. I'm pretty sure that I taught you guys PyQt in this class, and in fact I think you guys got a little tired of PyQt, so we're not going to do a whole lot with it. And if you're just really tired of PyQt, you can just look at my solution and get it off the website. If you're tired of doing PyQt Python, I'll be providing my solutions on the website. But you guys that are a little more adept and a little bit more patient, you might try to go ahead and see if you can get those graphics going in Python for the homework assignment. Okay, guys, I hope you're enjoying the class as much as I am. It's at this point that I always give a shout out to my Patreons. I would not be able to continue to provide the quality, in-depth content week after week without the support of my Patreon. So thanks a lot, guys. You can also help by giving a thumbs up to the channel, to the video, leaving a comment down below. Those will help me with the old YouTube juice. If you haven't already subscribed to the channel, when you do, ring the bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like engineers and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.